Can you hear me?
Yes, sir. Yes, yes.
Yeah.
Yeah, yeah.
Good evening to all of you. First of all, I uh, thank CBIP and CEA to invite me to share my thoughts on this topic. Cyber physical interface, case study on solar, wind, colonial pipeline, black energy, Stuxnet, lesson learned. The area is too vast and scope is also very gigantic, but I'll try to give a justice in this stipulated time. I thank all the authorities of CBIP like Dinkar sir, Sanjeev Kumar sir, Singh sir from CEA, and most importantly, the coordinator Akshay for doing this conversation goes smoothly along with his IT team. So, coming back to the today's topic, the things which I'm going to cover or focus. Firstly, introduction will have. Then I'll begin with cyber physical interface. Though this part was not mentioned in the brochure, I requested CBIP to include it. The reason was mere talking about cyber things without physical systems for which we as a power system engineer trying to know what the repercussion of say cyber attacks and cyber security aspects. It's important first to know about what this cyber physical interface, etc. And I'm thankful to them. They accepted my request, suggestion, and allowed me to include it. So first we'll discuss that. Later on, we'll take on the case studies. The first one is related with the RE sources, wind, solar, etc. happened recently across the globe. Then we'll focus on another infrastructure which was targeted by intruders, though it is not power system related, but the mechanism how it worked, what was happened is important to know because this type of scale of attack was having a lot of complexity. So for our power system, power sector as well, we need to understand what exactly that is. So the case study on Colonial pipeline, which was asked to consider, will focus on that. Then we'll focus on the case study on Stuxnet, that is Iranian nuclear power cyber attack. Then next case study will cover Black Energy 3 related with Ukrainian power system. At the end, we'll conclude sum total of our discussion and what is required as far as cyber threat and cyber security is concerned. So generally, I like to start with this basic slide to give an idea as to what we were and what we are as far as installed capacity of generation is concerned in India. You can just see during independence we just had 1300 plus megawatt, whereas now we have 4 lakh plus. And out of that, the share of RE is huge, 1,77,000 plus. And in coming years, we are dreaming, targeting to have RE power. Hello, can you hear me? Hello.
Yes, sir. Yeah.
Yeah. Okay.
Yes,
No,
sir.
I
Yes, sir.
heard.
You are audible, sir.
Okay. So no, I heard something, so I was unable to understand what if anybody is trying to interact or something like that. Anyway, I'll continue. So in the years to come, we have a plan of RE of 200 to 300 gigawatts to be added into the grid. So definitely, if we are going to gear up for that, we need to know about the challenges like that given in the topic of the subject today, that is cybersecurity threats and repercussion, and what we should do not to have it into the system in India. So from that angle, it's important to know these case studies and background. Now coming to the first part, that is cyber physical interface. As we being a power system or electrical engineer, we know very well about what the power system is. Power system components are like transformers, circuit breakers, CT, PT, etc., etc. Similarly, we have a set of components from IT end like computers, servers, routers, switches, etc. And most importantly, to bridging the gap of two cyber and physical, a communication network in between. So all this will make you a cyber physical system. And it is seen that it is observed that out of cyber physical system, the combined domain of cyber physical system is most vulnerable along amongst all the domains. So generally when we are talking about a cyber attack on a power system, it is on this CPS domain most of the time. And what are the attack strategies adopted? What the attacker does initially? It does a surveillance or a reconnaissance or a reiki, you can say in the defense word, much more before what the outcome of an attack seen to the world. Then they find out the vulnerabilities. Then they do the intrusion or dropping. Then they get access through some malwares or viruses, etc., and install that in the system to which they want to target on. And if they are not getting success on their initial attempts, they are very persistent in doing trying their attacks and infiltrate into the system. Then they deliver their payload. And lastly, what they do is not to have anybody trace them, they clean up the things. So this is how, in general, what the components of a kill chain, which is generally seen in case of cyber physical interface. Now, what this CPS or cyber physical interface will try to know, I have given a just broad diagram. At one end, you have transmission and distribution systems, substation components, etc. Then there is a line in between, that is a process control network. There is a HMI, data exchange servers, database servers. Then if you are doing some studies, you have simulation and simulation servers as well. And at the end, other end, your virtual private network connected with many other servers. You have PLCs, IEDs, RTUs, relays, numerical relays, and all the systems. So this will give an idea about what cyber physical system is. So what does an intruder do? You have a system in which intruder can go from your network, a local network. It can get access to your modem. It can get access to your any communication system. Though it is shown just wireless, it can be anything. It can be VPN, it can be RF, it can be fiber, anything. And then it tries to crack the firewall and have access to devices like routers, switches, and then, if possible, if their intention is to attack the physical systems, then the components of power system like breakers, meters, relays, etc. So this is how intruder establishes a attack path into the system or cyber physical interface. So generally, what the focus of this first important components include what attack damage is, attack analysis is, attack defenses, and attack detection is. All these components are very important when we are talking about cyber physical power systems and its attack. So this is how a attacker tries to get established. Attacker establishes unauthorized connection. He tries to connect valid user. He connects through the network. Then after spoofing, he reconnects. He gives the impression that he is working like an user. And then if he succeeds, the whole field is there for him to play on. Now this is one more example of how the CPS system, that is cyber physical system, and its consequences vis-a-vis its impacts. Here I have given three case studies. case 1, case 2, and case 3. The case 1 is a small local management system s- confined to or a constraint to a substation. Case 2 is a substation connected to some control center or some another neighboring substation, and case 3 is a substations connected to the control center with synchronized data coming, where you can have SCADA system running, WAM system functioning, etc. So before going into the details of these scenarios, I would like to have some focus on how this is related with the power system. Being a power system engineer, I'm interested to link it up to the power system, and all this background is important for us to understand the cyber attacks which we are going to discuss further. So uh, when we talk about power system, you know what the states in which the power system runs, and we also have idea about what is power system stability and its scope. So can anybody tell me as to what the power system, how would you classify the power system stability? Can you can you can anybody tell as to how the power system stability can be classified, because it is related with these cases?
It may be quality and availability.
What? Pardon?
Quality power means the proper availability and with proper voltage and frequency means availability
uh
of the quality power.
no, quality power is a different aspect, sir. What
Yeah.
my question is, how would you classify the power system stability?
Okay. Stability maybe synchronization between demand and supply. How to control the overall flow.
Mm, okay, let me begin with some basic things. uh, can
Sir,
anybody give about?
whenever
Yeah.
there is a system disturbance, either
Mm,
in the steady state or in the transient form, then the
mm.
system come back to its original state of steady state of operation. That is called the stability of a system.
Yeah, that is true. That is right. Very right. But my question is not as to what is power system stability. My question is, how would you classify the stability, power system stability? Because understanding of that is very important to understand what this local management, centralized management, and grid-wise management is and its impact vis-a-vis small, big, and big collapse. Okay, let me tell you. See, power system stability, our friend has told what is power system stability, that is true. But power system stability can be defined with a new definition of power system as a short term stability, steady state stability, mid term and long term stability, frequency and voltage stability. So, when we are talking about steady state stability, in this, the system recovers within seconds. When we talk about a midterm and long term stability, system is supposed to get stabilized within minutes. And when we talk about a long term stability in which system is recovering after a big impact like collapse, then system may take hours, or in case of blackouts maybe hours or even days if the impact is so big, like 2012 blackouts happen in India, to get recovered. So this is how the uh, power system stability is defined, and the quantum of this will decide its classification and the manner in which the states of power system will change from normal state to alert state, from alert state to extreme state, from extreme state to emergency, and from emergency state, if we are unable to take any control measures, protective measures, then the system enters into the collapse state, during which generally we find system is facing blackouts sort of a thing. So whole this scenario is blackout scenario happens if system is not acted upon timely to control the effects, ill effects, where the synchronized data's measurements are going from many substation to control centers in a case 3. Whereas in case 2, you have smaller part of a system getting affected. Whereas in case 1, a very small component of a system is getting affected. And this, whatever impacts or say threat perception to the power system, which we see due to physical operations of the system, can very easily be imposed by cyber attacker through its attack. And that is how we are interested to know basics about this, and then linking it to the same to the cyber attacks and threats and its repercussion during our case studies. Now, going to the next aspect, when we are talking about cyber system and physical space, both are interconnected, then what are the attack points? Attack points, you can see on the left hand side, physical space is there. On the right hand side, there is a cyber space. So either there can be a physical attack, there can be a cyber attack, or there can be a combined. But what type of attack it is? The alphabets indicate the type of attack. So in figure, you can see A means it's a physical cyber attack. B means it's just physical attack. CIM means it's supply chain attack. Supply chain attack means any component of a power system like hardware, components, etc. and its use into the system when it gets affected. It's called as a supply chain attack. Or DHL, it relates to firmware modification attack. As we know, we have different types of firmwares for relays, meters, IDs, etc., RTUs, etc. So the attacker can modify that firmware and hamper the system. FJN indicate network-based attacks. That is the manner in which the systems are connected locally, remotely with LAN, WAN, or through computers. EGK indicates the code injection or replay attack. So these are the variety of attacks which the attacker can take charge of to impact the CPS, that is cyber physical systems. Now, what are the different applications? I'm just giving you a list. Since being a power system engineer, we all know this, but still I'm listing it just to know what could be the different application that could be impacted by cyber attacks. So there is most importantly one which we are going to discuss today uh, multiple times is a SCADA. So I have taken it on the first. SCADA, EMS, AMI, automatic metering interfaces, DSM, deviation settlement mechanism, as well as DSM is another for demand side management that also can be impacted. Then wide area measurement systems, special protection system, which are also called as SIPs, that is system integrity and protection schemes, asset management system, DFR, that is digital fault recorder, geographical information system, operation market operations, including their related software, real-time market operation, their management, dispatching and scheduling, including REs, surveillance and security system provided in CCTVs, online security checks, etc. All these applications do have all the components like hardware, softwares, communication system, which which are very prone to cyber threat. Now we'll come to the first case study. With this little background on what cyber physical system CPPS, that is cyber physical power system, we'll come to the first case study. That is case study on solar, wind, our resources and lessons learned. As I mentioned in the brief of introduction, that since we are also focusing a lot on REs in coming years. Yes, any question? Any question? Okay.
No, sir, you can continue, sir.
Okay. Since we are focusing on REs in coming years, we ought to give attention as to what are the challenges or what are the things happen into the RE perspectives, RE systems globally when we talk about their functioning and cyber attack or a cyber threat. So the first case study involves the cyber attack on satellite communication, which impacted the Enercon system. The Enercon is one of largest wind turbine manufacturers and RE system developer in Germany. Second case study which we are focusing on this is the ransomware attacks on Nordex and Deutsche Windtech, again German companies. And the third case study which we are going to focus on is a espionage campaign which Chinese operated on wind energy sector companies which located and operated in South China Sea. Now here there is one important aspect which we need to consider, that the cyber threat or a cyber tool has become a popular tool for some nations to use against their uh, foes or enemies, or to get advantage or a leverage against others. So this is exactly what has happened in this espionage case campaign, though the things focus were something different. We'll see it what they are. Generally, when we are talking about any system, we need to have some strategies. There is something called as a R4 strategy. That is robust. The system should be robust, redundant, resourceful, and rapid in response. When we have such system, that system is said to be a stable or uh, properly functioning one. If not, then definitely there is a threat perception exist. As far as wind farms and wind turbines are concerned, this R4 principle is very well seen in case of protection against natural calamities like turbine winterization, provision of internal brakes preventing turbine blades going overspeeding for a longer period, remote monitoring to address maintenance concerns predictively or proactively, etc. But it is hardly seen in case of cyber resilient designs. And that is the reason this system got impacted. Now, before going to what happened to the wind turbine and wind farms, I would like to give us some basic general background. Maybe this is very basic for those engineers who are working in RE industry or at the field on RE industry. But still, for others, it's important to know what the wind turbine comprises of. It has a PLC, it has brake, pitch, etc., electronic systems, shaft. Now, when we are talking about wind turbine, the wind turbine has two basic functions. It has to see the direction of the wind and the turbine should face it. So that is determined by PLC, and PLC helps yaw, and the angle of the blade, turbine blades, that is the pitch is of a turbine, is again decided by the PLC. So PLCs are very inevitable part of a wind turbines which were focused by attackers during cyber attacks. How we'll see further. So generally these wind turbines or wind farms adopt different communication system and different protocols like control area network, Ethernet for control automation technology, Ethercat, Modbus, Profinet, etc. If it is Siemens SCADA system, they prefer Profinet being their own protocol. If it is G, they prefer to go for Modbus or OPC. Now we'll see how the wind farm communication system or infrastructure is actually. This is important to understand because in further discussion, we will see this very communication of wind farms was focused by attackers to hamper it or damage it. So you have turbines, turbines connected with various communication links. Then you have VPN network, industrial Ethernet, and all this is connected to the control center, local as well as remote through uh, internet to their business offices, wind farm developer or wind turbine manufacturers, different agencies which are involved in maintenance or supply chain management related suppliers. So when we see a wind turbine and allied systems, what we can see is turbines are communicating a large amount of data to the centralized field control center. They transmit around 1,000 data points per turbine and 1,000 data points per on-site substation. So just imagine with such huge data, if very few of them are also targeted by a cyber attacker, it can have a havoc into the system misoperation. So to give a better idea of how the wind turbines are connected at the site and how they are interconnected further to the control rooms and control centers, this diagram gives you a better idea. You can see multiple wind turbines are arranged in a fiber ring. It is a IP-based communication, and generally less than 20 wind turbines are connected in single fiber, and they are daisy chain type. This further is connected to local control center, as well as this local control center further connects to the control center or state load dispatch center after pooling station. So here there are every chance of, even if a single wind turbine is affected or had access remotely, it can have an impact on other connected things, other connected turbines. So the attack horizon becomes wider. Generally, there are different types of wind farm SCADA system architectures which we have. One is standalone, as seen. Wind turbines are connected to local systems, cyber systems through Ethernet and LAN. In second, they are partially integrated with the network where they may be connected with corporate LAN with a firewall. In a third case, they are wide area network connected. That is, different wind farms through WAN are connected to the main control center where they are dispatching the RE data from where the RE monitoring is going on. Now, with this basic information of wind farms, their interconnection, their communication system, how they are connected to the control centers, we'll try to know before going to the case studies how an attacker could impact these wind systems, wind farms or wind turbine systems. They can have an impact on wind turbine control. Wind turbine can be damaged. Wind farm can be disrupted or damaged. So also substation to which the wind farm is connected can be disrupted or damaged. Engineering workstation can be damaged. The data, the wind RE sites or REs have a lot of data, right from weather stations, weather data, local wind data, and the data which are supposed to send to the control centers, all the power system parameters, etc. That is stored in the historian, that all can be attacked. And the wind turbine sensor, there are a lot of sensors, the variety of sensors available, they can be attacked. In one case, With the help of the tools available today, one cyber attacker can operate the state in which turbine is running. That is, whether it can decide whether to start the turbine or stop the turbine. Though the things like uh, winterization of turbine is not yet been attacked by the attacker, but in days to come, this can also be a focus point of a attacker. So this can be possible to the attacker only with a remote access. And the major reason for ransomware attack on corporate networks impacting wind turbine vendors and maintenance companies in 2022, that is last year, was this remote access provided to the vendors and technicians. Apart from this, the Department of Energy USA, in its niche cybersecurity report framework, has identified following things to be ensured for security of a cyber systems. That is, internet service providers should be focused, wind plant owners should take the responsibility, so also wind turbine original equipment manufacturer to take the responsibility, and component suppliers, those who are supplying the components to the RE developers, RE sites, so also the substation to which these RE systems are connected. All of them should be careful to have systems at place to protect from such attacks. So they have identified 8 areas which are needed to improve as far as cybersecurity is concerned. A research to develop better technologies, tools for wind energy cybersecurity, conduct routine cyber assessments, define cybersecurity roles, responsibility within wind entities and throughout the industry and supply chain. What should be the emergency, cyber emergency response and preparedness that needs to be done with exercise done. Develop robust, consistent cybersecurity programs at wind facilities. Developing cybersecurity standards for wind technologies. So this was as far as onshore wind turbines. But nowadays, there is a boom in offshore wind turbines also, or offshore wind farms also. Though India is yet to tap this offshore wind farms, in Europe or in America, this is a very widely used system, offshore wind turbines. So just imagine if in case of onshore wind turbines, you are getting hurdles in managing the things, what could be the impacts for those wind turbines which are there at the sea. So offshore wind turbines are generally connected through a cable to the nearest substation, then later to their grid control center and their communication through communication system to their corporate office, business centers, and local centers. So, what are the viable attack points which are not limited but important ones are the cyber access via vendor network, the access to given to the technician who is managing maintaining the equipments, or cyber access via compromised supply chains, that is supply chains which is needed for uh, proper upright working of offshore wind farms. Now coming to the first case study, that is collateral damage of satellite communication impacting Enercon wind turbines. In this, if you see, this is in the backdrop of the currently happening war between Russia and Ukraine. This was not the ultimate goal of an attacker from which were supposed to be the state sponsor from Russia to attack a energy company, that to RE energy company from Germany. But what happened was a collateral damage happened. They were supposed to attack the satellite system which is helping Ukrainian army or Ukrainian defense forces, but the service provider giving services to the defense in Ukraine was one of the European company having a US subsidiary, Viasat. So in that attack, many of Viasat modems, STATCOM modems, which are connect, connected to the wind turbines, there are 5,800 in numbers and spread across 1,217 wind farms operated by Enercon company of Germany, got affected. This halted their working because the satellite system communication system itself was attacked. This did not result in into the say supply disruption sort of a thing or a generation loss sort of a thing. Wind energy continued, but the impact was it could not be monitored. Around 10 gigawatt of wind energy could not be monitored on SCADA system. When in-depth analysis of this attack was done by Sentinel company, cybersecurity experts, they have given the malware which is a Viper named Acid Rain. Viper is a, as we see, a wiper of a vehicle or a car which wipes out the rain, water or a water and cleans the glass. In the similar fashion, this Viper malware cleans all your data. And this Viper is named as Acid Rain. In this, what happened? The VPN appliance got compromised of that of KSAT Statcom network, and that has resulted into the satellite communication of around 30,000 Satcom modem terminals of RE entity getting affected. This is how a replica of what happened actually. The communication portion shown in red is the communication portion affected due to this attack, due to interconnection to the satellite modems during this attack, which is connected further to the SCADA system, Enercon SCADA server. So from this, you can get idea as to uh, how the communication system of REs got affected. Now, what are the lessons learned out of this study? The first lesson is the communication system attack of such a big scale is a remarkable and takes a lot of time to recover. Now, when after this attack, Enercon tried to settle down the things, bring back this SATCOM modems to normalcy, they literally took more than 2 months. Though I have written 2 months, they took more than that. And even after more than 2 months, they could restore only 95% of impacted turbines, bringing to the normalcy, that is giving their data to the SCADA system. And rest of the 5% was uh, communication provided by mobile communications ways like LT, that is long transmission evolution. So they have used. So your power system got affected and the response time was bigger. So whatever R4 strategy we talked in the beginning, that is rapidity in response, that was not seen. And this was because of there was lack of redundant communication system available at the site as well as between the site and the remote control center. Then when we need to develop a redundant communication, definitely it comes with the cost. And if it has to come as a redundant communication, the developer or entity responsible for that must consider it with a burden to the consumer. Now here comes the regulator and stakeholders, all stakeholders, including consumer, distribution companies, transmission companies, whether they are going to accept it or not. STU, state transmission utility, who gives them uh, approval for getting grid connectivity. So all this needs to be seen, looked into in very policy framework seen scenario if we need to uh, ensure that redundant communication has to be there. So the servers impacted, communication system was impacted, so the SCADA and control system also got affected. So this is how we see a RE company or a RE asset entity getting hampered with a cyber attack. So lastly, I have written, if this is what happened to the onshore shore disturb RE system to get normalcy within 2 months, just imagine what could happen to a offshore wind turbine or wind farms to get restored, and imagine the impact. And that is the reason it is very important to know, uh, focus on the security aspect and the challenges to be mitigated on. Now coming to the second case study, that is cyber attack on wind turbine manufacturers. Now earlier case study was a cyber attack on actual RE system at the field, whereas this is a cyber attack not on the actual system but the manufacturers companies which are responsible for providing the components to the RE system. So what happened in this case? On 31st March 2022, Nordex Group, again a German company, and all this happened, if you see, all this has happened during the period when invasion of Russia on Ukraine had started. So it you can say that there is something like a state sponsored things seen, though it is not accepted or agreed or seen as accepted globally, but there is a point in saying it. Now when this cyber manufacturers were attacked, wind turbine manufacturers were attacked, it was not just simple attack, but it was an attack of ransomware type. Means the system was attacked and some amount of ransom was demanded to do away with the attack by the attacker. So, uh, what immediate step the manufacturers took was, as per crisis management protocol they had at that time, was to shut all the IT system across the multiple location and multiple business units across the Germany. So they disconnected all the IT systems, IT supports from their physical systems. So out of cyber physical, cyber has gone, only physical system remain. Similarly, in same manner, on 11th April 2022, another wind turbine maintenance company from Germany that is called as Deutsche Windtechnik also experienced ransomware attack. It affected company's IT systems, resulting in disabling remote connectivity and control to over more than 2,000 wind turbines across Germany. Just imagine 2,000 wind turbines across the country. When such type of attacks are initiated by the intruder, what they do is they attack and they put a note with the attack that so and so amount as a ransom should be paid. Once that is paid, the system can be made okay. So the onus now is on the one who were attacked with the approach not to pay and restore the system on their own or with the help of cyber experts, or accept the demands of the intruders or cyber attackers to give them money, and that is ransom, and uh, get the system running properly with the help of an attacker. Now in this case also, this ransomware attack, the loss of communication system between wind turbines and remote control monitoring and operation centers SCADA took place. So what was the same, like redundancy in remote communication and centralization monitoring of operation of wind assets essential, and the immediate action taken by these companies to safeguard the larger damages of their assets and further RE generation is to cut off IT systems. But this cannot be the way or a solution to tackle such situations. So we need to uh, see the plan B to handle this situation. In further discussion of mine, I'm going to give focus on that as to how this can be done. So I'm not going to discuss this at this point. So with these two case studies, we can see that variety of wind turbines and wind farm related companies have hit because of their remote access given, which helps cyber attackers impact on wind farm generation. Now coming to the third attack, it is again related with the RE system. But if you see this attack, the objectives were totally different. In March 22, a phishing activity was initiated by Chinese hackers. Now this is not by Russia, this is by China, and this is done in a location which is seen to be very strategically important for all the major powers in the world, that is South China Sea, where China claims it's theirs, and where US and other world powers also say they have their claim. So what happened? The offshore wind farm on the Strait of Taiwan, that is Yunlin offshore wind farm, was attacked, affecting their supply chain. And the supply chain was such badly affected that it affected into the resulted into the project experiencing delays in its completion, as many contractors who could not supply the required components materials at this site, they have terminated their contract and left the project. So see the impact. It is indirect impact on RE. It's not a direct impact like in previous cases. Means whatever targets which you have to have power or a generation through a certain particular source to come by particular date, the very much can be affected with cyber attack. But this was not the so. There is something else also happened further. There was a big campaign or a espionage run by Chinese, and the malware used for this was named Scanbox. This campaign or espionage trail ran from April 22 to June 22. And what was done? In this, a URL was sent, supposing it to be a Australian news daily, the morning news or a media company sending, giving a mail, which was fictitious actually. And the moment you clicked it, the malware used to enter your system, and the specific targets were the heavy industry and manufacturer responsible for the maintenance of offshore wind farms. And this activity was done by a malicious group called Red Laden, which is a China based espionage motivated threat actor. And the very objective of this is not to directly impact but indirectly have a benefit out of hold the data, hampering the supply chain, hampering the project execution, and having edge to the Chinese companies their business interest into this area and against their rivals. So it highlights the threat perception of global wind energy sector uh, is also from the point of view of business development, because data can be stolen, data can be uh, used to propagate their own business interest. And the entities involved were vendors, turbine vendors, wind farm owners, SCADA providers, system integrators, software providers, grid operators, energy market operators, analysts receiving data from RE entities. So all this can be focused with espionage to get an edge. So this is how the three different dimensions of cyber attack were seen as far as wind farms and wind energy is concerned. Now we'll move to the next RE segment, that is the solar. So before that, I will sum up. I have pointed out what what are the general takeaways of a case studies, like lessons learned. What we need to have is, most importantly, resiliency in wind farm communication with redundancy. Secondly, multiple players involved in supply chain monitoring and management of wind sector makes issue more complex and enhances the attack surface. The more players you have, the more possibility of getting intruded or penetrated into the system. It's easier for attacker. So we need to have a shield against such threats. So we should have processes, time, and investment done to protect against all such things. And with offshore wind farms on rise, so also the distributed energy sources, these threats are going to see often in days to come. So we need to be very vigilant on tackling these issues. How we are going to cover in the next part at the last. Cyber attack on Enercon's turbines demonstrated that attack on large scale of this type on RE system or assets makes them very vulnerable to disruption and could impact state, regional or national grid. So a very important lesson for a country like India, which is aiming a big RE penetration with its output in years to come, is surrounded by hostile neighbors, to have a strategic plan to protect against cyber threat by adopting short-term, long-term plans when we have to achieve 200 to 300 gigawatts of RE to be added in years, coming years or a future. Now, coming to the next part, that is cybersecurity aspect related to solar. In this
I've got
case,
one question.
hello, yeah,
Excuse
hello, yes, yes, any question? Hello, hello, hello.
Cont- Please continue, sir.
No, so somebody said something I heard, so
am
I
I audible?
thought that. Yeah, you are audible, but
Hello.
you're. Hello. Yeah.
Sir, actually, I just want to know कि when we are talking about the wind turbine vulnerability and communication issues.
Huh.
So this 61400-25, that
Hmm.
is the SCADA communication protocol standard.
Hmm.
So in this standard, sir, it states that there are vulnerabilities in terms of it gives if we dive deep into the standard,
Yes.
it gives us four implementation: web services and then
Hmm.
other IEC 101, 104, and the other implementations as well. In
Right.
all these implementations, if we go, we see that it gives you optional values, and these optional values are generally activated by the vendors,
Hmm.
and the SCADA, and to control the wind turbines, and the SCADA is hosted online and remotely. In fact,
Right.
the OEMs as well as the developers both are of different of foreign nations.
Hmm.
So generally, they enable all these options which are embedded into this standard, and
Hmm.
exploit these shortcomings of the standard itself.
Yeah.
So what
Right.
is the way out? Because the standard itself is having shortcomings. So and different vendors implement it based on their different requirements. So how to overcome? Because the developers as well as OEMs both are of foreign nations.
Okay. So may I know who is this speaker from? Where you are?
So Neeraj Sharma
Neeraj Sharma from Cell.
from CSET Power.
CSET Power.
CE.
Okay. Okay. Oh, okay. Fine. See, the thing is, What you have pointed out is very much right, that there is a lacunae in the standard itself, and that is the reason the something called as C2M2 model is there, which we need to consider.
Right.
Okay, so I'm going to talk about that at the end. At that time, you will find, you will see what the things which you can see and ensure about. Okay,
चलिए ठीक है, okay.
now coming back again to the solar farms. When we are talking about solar farms, what we have is a PV array, unit controller, its connection with inverters, DC, AC both, its monitoring diagnostics systems, metering system, and its interconnection with the grid. So all these components are prone to cyber attack. So first one is the physical, the solar array itself. Second one is the inverter controller and algorithm. Third one is is supply chain, whatever components are going to get supplied. Then monitoring and diagnostic platforms, as you have to monitor how the sun is, how the solar panel position should be, what the data points, data sets we need to observe to have maximum tracking, etc. So, and it's diagnostic, all that with the help of software we do. So all those things are there, and its interconnection with the grid. So all these 5 points are points where a cyber attacker can attack. So generally what is expected, these are general things. Cybersecurity awareness and training programs, then use strong password, update firmware, keep list of highest cybersecurity risks and how they will be addressed, auditing of your OT and IT infrastructure, proper network segmentation for IT and OT components. Photovoltaic plant owners and operators should have visibility into the devices and in the network. Keep critical access of ICS behind firewalls. Remote access communication should be logged and monitored, and develop and review the incident response systems, and AAA system of operation, that is authentication, accountability and authorization should be followed strictly. So in general, how easily can vulnerabilities be discovered should be focused. Once it is done, evaluate effects of cyber vulnerabilities, what are the physical impacts, how to avoid failures and cascading, assess and quantity risk assessments analysis. So various entities which needs to see, like stakeholder engagement is important. So also we need to take help of R&D, like there are many data analytics tools available now. We have machine learning, AI systems. We can make use of it to know, looking at the traffic as to what could be the trend and what should be done. So also PV and cyber security of industry, self-evaluation, defense in depth approach, which I am going to explain further how it can be implemented for a system. Insider threat mitigation and supply chain risk management. All this should be incorporated for a PV systems. Now, with this, we end our first case study that is related with the RE system, that is wind and solar. Now we'll come to our next case study, that is Colonial pipeline cyber attack. Though as I mentioned, it is not a power system related, but it's very important to see from the point of view of the scale at which these attacks were carried out. This is again a ransomware attack. So as the name itself suggests, a pipeline, it's a gas pipeline in a USA which got affected. So there was a situation like no gas over most of the eastern coast of USA, and people were running with the queues of cars to get a fuel on, but was not available. What happened? Actually, there is a long pipeline which is going from Texas to New Jersey, which is supplying around 50% of the fuel requirement of east coast of USA, running 5,500 miles. Just imagine the length. If we compare it with the length of India from south to north, it is not more than 3,400 approx kilometers. But we are talking here 5,500 miles. So such a gigantic infrastructure of pipelines needs to be monitored very carefully, and that itself was uh, focused by the attacker. What happened actually in this case? It hacker group named as Dark Side, it ransomware attack was responsible, which was a group, though it is not formally said from Russia, but it's very well seen that it is a Russian supported group. It resulted into 100 GB of data exfiltrated into the launch of encrypting ransomware. Darkseid breached Colonial Pipeline's infrastructure 3 to 7 days before the attack and executed a ransom payload on May 7. What was the chronology? Generally, there is a common signature seen in cyber attacks. They are not done exactly on the day on which they happen. There is lot of Reiki or reconnaissance surveillance done much before. So similarly, the same thing happened in this case as well. And though the attack started on 7th May 21 is what was seen, its reconnaissance surveillance started much before. So this is the timeline during which it started. And ransom of around 4.4 million was asked and it was paid also. When CEO of this pipeline company, Joseph Blount, was asked why you surrender to the attacker, he said it was very difficult initially for any one of us to know the impact of this attack to whole of this infrastructure. So I had no other option but to accept to the demands of the attacker. So the 4.4 million dollars were given, but considering the strong US government support, FBI, DOJ, Homeland Security operations, and President Biden was also very active with his message that he can disrupt the ability of attackers to operate, had sent a very strong signal, and the same was done. And the amount which was paid as a ransom, out of that 2.4 million were recovered. So what was the root cause? Root cause was exposed password for VPN account. Here one of the employee of this Colonial pipeline used the same password in another network, and this was the point where a attacker entered, and it impacted with a malware which was compressed and executable configuration file was sent with a ransom note encrypted. So if we see at a IT/OT network and how this Colonial system attack was targeted by cyber attacker, you can very well see that the Colonial servers were targeted, and because of the immediate steps taken by seeing at the attack to dislocate or separate out the system, the remaining system, the
Sir, I have a
bigger,
question.
yeah,
This is Anil from ERDA.
huh,
The same password is the issue, or the password is same plus weak password was there?
both the things, both the things. Same
Uh,
password was
I
main
think
issue, but weak password is again a issue in cyber attack. But in this case, it's the same password. The password which was used in particular VPN system of that pipeline network, same was used by the attacker, was by employee in different system network, and that was a case where in that different system that attacker got access to, and with that using those credentials they entered into the pipeline network. That was the thing happened.
Okay, sir. Thank you.
So what are the takeaways of this attack scenario and cyber event? The US government used intelligence communities resources such as cyber command. Cyber command is a command here. Let me tell you what is cyber command, which is established in USA. It's like a military command. They have established a command which takes into account all the uh, cyber security point of actions which are needed as a defense case for protecting the cyber systems in United States, and it has all the authority to act, protect, and have policies on as far as protecting the IT or cyber infrastructure within the country. So its cyber command is supposed to be the most strongest in the world. So they came into picture while dealing with this. Then timely action of downstream system offlining assisted reduce much larger impact of the attack. Reusing the same password as I mentioned is a risky, and Office VPN password should not be used elsewhere is a takeaway or a lesson learned. Next lesson is IT/OT system, its network along with interconnection should be adequately shielded against such attacks with standard guidelines and procedures for the same. And the manner in which government of USA, FBI, Department of Homeland Security, DOJ, that is Department of Justice, all of them acted in synergy was help them isolate the attackers and make them such aloof that they were unable to use any of the platforms forums to carry on their activities further, and they rather put message saying their intention was not to hit the US infrastructure but just to get the money out of such attacks, and they disappeared. Though it is a different story that they disappeared and worked with a different name, but a very strong message was sent by the United States agencies and government acting together. So this is how about a colonial pipeline cyber attack. Now, before going to the next part of the attacks, I would like to give some brief about what are the OSI model, what is the OSI model and cyber vulnerability. Now, all being a practicing engineer, we know what is OSI model, that is Open System Interconnection Model, and it's 7 layers. But out of its 7 layers, the most vulnerable layer is the application layer, and it is seen that as per report and studies
Sir,
most of the attacks.
before we move forward, we have one hand raised by Mr. Chetan.
Okay, fine. Yeah.
So Chetan, you may ask your question, sir.
Yeah. Yes, sir.
Mr. Chetan, Mr. Chetan Mavadia.
Yeah, yes, sir. Sir, are you audible, sir? Am I audible, sir?
Yes, audible. May I know
Yes,
from
sir.
here
My
you are?
question, sir, I'm from SR Power.
Okay.
So, sir, my question is that you said there is a problem with the same password entering, that's why attacker got. So
Hmm.
they maybe in AD they use so AD having the same password.
What is your question? You are not clear in your question.
Same question is that is they whatever people are attacking using by the VPN, right?
Hmm.
VPN having a password which was used same attacker,
No, 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 no.
right?
Attacker has not used it. You understood wrongly. Let me correct it. What I am saying is that employee of a power that Colonial Pipeline company, which was working in their system in their own VPN, suppose he is having ABC as a password. He used the same
Uh,
ABC password in another system where he used, which is not a office but another system. And
But
that
sir,
password,
in this,
that
yes, yes,
pass,
sir. Now,
that
now in the
password, that password, let me complete first, sir. That password got access to the cyber attacker, and they use this because these cyber attackers are doing their trial and errors, brute force techniques to enter. So the moment they got that password, they were trying, they got the access. This is what happened.
yeah, sir, but sir, maybe they have using AD, so in AD have a same password, right? Whatever
Means,
employee is
hmm,
there, they
hmm.
are using maybe AD. So AD having a main same password. They don't have a another password, right?
No, that is what I am saying. In this case, what was done by the employer should not have been done. In fact, the password for different VPN should be different. Okay, the password used for one VPN should not be used for another VPN. This should be the basic thumb rule must be followed. A password used in one particular network should not have been used for other. Repetitiveness of a password should not be there. Is the first basic thing of having a good password, which was at flaw.
Okay, okay, okay. Got it, sir.
Okay,
Thank you.
okay, thank you. Now going next,
Sir, we
uh,
Sir,
have one more.
yes,
Yes, Mr.
sir,
Neeraj, you can go.
yeah. Thank you. Sir, I just want to know actually there was some break in the signal and all. I just want to
uh-huh.
know what did the US government do to bring the hacker group onto their knees? What did they do actually?
See what happened. There's a hacker group which was understood to be from Russia acted because unless and until a state gives support, they cannot do such kind of infrastructure attacks of another nation. So first thing which happened was there was a meeting between Biden and Putin at Geneva, during which this issue was very highly taken up on the agenda, and the signal was given from the US that if this has happened from Russian soil and is Russia is silent to not to take action on, then the same can be retaliated on Russian infrastructure. So that was a very strong message. Secondly, what all these agencies, cyber expert from USA, CERT USA, then the cyber command which was active, what they have done is they identified the group which was responsible for this, and they have cut off their all communications, their interactions, the groups, cyber attackers, intruders, interactions with the group forums, their access to have their uh, malicious activities going. They stopped that. So that sent a very strong signal to the attacker that, and they also send the signal that if this happens, then the same thing can be happening to the attacker. Whatever money they have from this activity as well as whatever they have earned from other activity, same can be taken back. So that was a strong signal, and that is the reason the attacker were able to uh, return the money, $2.4 million out of 4.4. That was the success. And even they posted on their group that we intended not to attack US as a state, but we in, acted, intention was to have a money. That was our objective. And they stopped working, functioning.
Okay, sir, a follow-up question to this. Thank you for
Huh?
this explanation.
Okay.
So it means the US cyber security officials were
Hmm.
present on the dark web. That's why they could able to stop their
Where,
communication channel.
where, where?
In the on the dark web.
Yes,
Their presence
definitely.
must also
See,
be there.
all this, see, very interestingly, the dark web, which was very known to everyone in India due to Sushant case, is very much active in dark side, and most of the cyber experts of most of the countries are very much active in it. They know what is happening, who is doing what, and they are also actively monitoring and taking countermeasures.
Okay. Okay. Thank you.
Okay. Yeah. Should I continue further?
Sir, I have a question, Anil here. Following, say, what is the probability or possibility nowadays to do a counter attack on a hacker, right? And what are the success ratio? Because now the technology are different and tracing back to the counter the attackers is quite difficult. Is there any
May I know?
cyber surveillance? Yeah, this is Anil Solanki from ERDA, sir.
Okay. See, the threat perception is a dynamic. It can't be static, as you know. So, what you are asking, trying to know is what could be done, etc. So, there is no single solution to all the things. You need to act as per the situations.
Another supportive question was that is there any cyber surveillance available that we can trace back to the attacker?
Yeah, that is
Is
very well available. There are softwares available. There are companies providing software which can have surveillance, reconnaissance. You can take help of it. There are service providers giving this type of services, but they are costly and again risky also.
right?
Okay, coming back again to our presentation. Now, before going to the next set of case studies, I would, as I was discussing, uh, OSI model and cyber attack vulnerability. It is seen that the application layer is most vulnerable, and as per report and studies, 80% of the existing system vulnerabilities are associated with it. And that's the reason close to 90% of the cyber attacks in power grids are aimed at application layer. So application layer may be anything, and that is the reason why in the beginning I shown you all the list of application. So all those could be the application layer which can be affected. From that you can just imagine how wide the horizon of this cyber attack is. Now coming to the next case study, that is Stuxnet. It's very famous. In fact, first cyber weapon it is called as, because this is the first uh, attack by a cyber system like a weapon on uh, power installations. So this is related with associated with the Iranian nuclear power plant located at Natanz in Iran. So what was the speciality or say characteristic of this malware used to carry the functionalities? If you compare with the common malware, its size was just 500 kilobytes when if compared with others which might be going into the megabytes and above. It penetrated with flash drives, that is pen drives. And if you see the exploits, generally uh, any normal malware can have just 1 0 day exploit, but it has 4 0 day exploits. And its target was industrial control systems. And it was extremely selective. It was, you can say, a very smart, intelligent software code malware, the Stuxnet, which knew what it has to focus on and what it has to do. So, what happened actually in this case? This worm was a malicious masterpiece code, I would call, which was attacked in three phases. That is, first, it targeted Microsoft Windows machine and networks, repeatedly replicating itself. Secondly, it sought out Siemens Step 7 software, which is also Windows based, and used program industrial control systems to operate equipments like centrifuges. And finally, it compromised the PLCs and affected its functioning, further resulting into the centrifuges to get damaged. Now, in short, what happened? Before going to the nature of the topic, I would like to give a background of what the centrifuges, systems, etc. Centrifuges is machines which are present in the nuclear power plant, which isolate the isotope and help in enriching the uranium. So the first picture is that of centrifuges, whereas centrifuge parameters being monitored is shown in the second. Pressure controllers maintain the cascade is seen in the next, whereas a liquid display indicates the gas pressure is shown in the next. Now here I have written UF6. Here UF6 is nothing else but uranium hexafluoride. As we are very much known to sulfur hexafluoride. Similarly, there is something called a UF6, that is uranium hexafluoride, which is used in enrichment plants in nuclear plants. So it solidifies at 100 millibar, and if it solidifies, then it destroys the centrifuges, and exactly that is what has been done in this case, and that too with the help of cyber attack. Now, how this Stuxnet worked? See, as I mentioned in the past, that this is a very intelligent malware which knew what to attack on, for how much to attack on, and what not to attack on. So, regarding this centrifuges, let me tell you one more thing, that these centrifuges, when they are into the act of separating the isotopes of uranium, they re- revolve at very fast rate, a rate something like thousands of RPMs, and their bending frequency is given in hertz. The hertz shown here is not our frequency hertz, it's a bending frequency. So what this bending frequency of centrifuges? So what this Stuxnet has done, it played with the
Sir,
spin rate. Yeah,
sorry to disturb you, sir. There is one small question from our participant that what does the term 40-day attack mean in the
okay.
chat box?
Yeah. See, 0 day attack means it's a type of attack in which uh, the day on which attack has happened, on that day there is no solution to counter the attack. Only the one who has designed this attack through Trojan, malware, or whatever knows how to do it and knows how to stop it. Apart from that, nobody has an idea about it. So it uses the system vulnerabilities, and this malwares especially are designed to work for which there is no solution exist on that particular day. Okay, is it clear? Hello,
Yeah, I was
hello.
asking for, I think somewhere you mentioned the term 40 day attack.
Right.
So I was with 4 day,
Yeah.
0 day and 0 day. I mean, so I was
Yeah.
just bit
See.
confused. Somehow.
Yeah. So the thing is, if suppose uh, 0 day means, if suppose I'll give you an example. It need not be the case in this case of Stuxnet. Okay, it's a generic example. Say if suppose uh, since we are talking about power system, as an attacker, say I'm an attacker, if I focus on to play with the frequency and whatever frequency of the grid, okay, so if I write a code to disturb the frequency of the system, the grid, because of which the controls being taken uh, across the system are hampered, and whatever malware I develop to disrupt this system frequency are not known on that of day, then that one parameter getting affected with such malware is one parameter, that is 10 day. Like that, if suppose I focus voltage, if I suppose focus active power, reactive power, four parameters I have considered. All those are of such characteristic that till that day there is no solution to find out what are the root causes of that, except from those who have developed it. So in case of Stuxnet, there was four different ways in which this was done. Whereas in general normal case, only 10 day kind of a approach is followed by attacker. That is the meaning of it. Got it?
Yes, yes. Thank you so much.
Okay. So coming back again to this discussion, that the centrifuges had a function of separating uranium isotopes so that it can further use this enriched uranium, which we call as, for nuclear reactor or nuclear weapons. And the very reason for this attack was a US, Western world, and Israel did not want Iran to develop their nuclear capabilities. Though no one has claimed openly that this is due to USA or Israel, but off the board, it is believed that both of these are responsible for this attack systematically. So what this Stuxnet did, the spin rate of a centrifuge, it adjusted, and see how silently done. And that is the reason it is called as a stealth weapon, stealth cyber weapon. That is a Stuxnet. It increased the speed of rotation of a centrifuge to 1410 for 15 minutes, then kept quiet for a long time, that is 27 days. Then it slowed down the rate of centrifuge to 2 hertz for 50 minutes, again slept for 27 days. And this continued over long time. So operators seeing it was not able to understand as to what has happened or used to ignore it. It's something which generally in operations we see. Say system parameters or systems are not always normal, they fluctuate. So something like that might have happened. That was not the case. But so what happened, how it worked, infection through pen drive was a main reason. From one network to another, one PC to another PC, it went through the pen drive. Then it started searching the systems, computers, which it was to focus on, like the cement system and the controller, which was controlling the centrifuges, its systems, etc. It was targeting that. So all the system and computers which were not related with that was not the focus of this malware or Stuxnet. So it was intelligent in that way. Then it updated. Next, it seen into the what was the compromised system and carried out a 0 day get use of or made benefit of a 0 day vulnerability. Then it took control over this system lacune and decided further to impact on centrifuges. And the moment it impacted, it has resulted into lot of centrifuges. If you go by number, more than 2000 centrifuges in Iranian nuclear plant got damaged, literally broken because of this attack. And this has uh, left Iran nothing else but to only option to shut that nuclear facility. Though Iran had never accepted that it was due to this Stuxnet attack, but the very objective of those who are responsible for this, for Iran not to be a nuclear power, got at during that time got success. So, in short, the worm spreads on its own. It found, it focused its target on its own, and from where it disrupted the centrifuges. And during this, the second type which followed was it used the certifications, which generally any software like Microsoft does get a certification from some certifiers saying that their software is okay with no lacunae. So such certification obtained were shown to be real ones, though they are fake, and that all was done by malware. That was the second 0 day. Like that, there were 4 0 days involved. So what was the security constraint observed, and what are the lessons learned? What should have been done in such cases? The first one is operational results.
Amit
As-
Ji,
yeah,
Islam here.
uh,
Basically, just wanted to understand. One is like, if the attack has happened in the nuclear plant, I hope, because these are very sensitive area where internet doesn't present, so it was just got,
this was a
I think,
virus which could
through
spread without internet.
pen drive. So all
Yes.
the program was written in such a way that without the instruction or something, it act in the
Yes, and that is the
background.
reason.
And
Yes, yes, and that is the reason it is called as an intelligent program code,
okay,
which
and
which could
how
direct itself, and that is the reason, as it was intelligent, so it could detect which system, computer, control, PLC to focus on. If it is
correct.
not centrifuge, it use hardly to ignore it.
Then tomorrow, if such a case of war where world is getting, targeting one country is targeting to another country, let's assume there's a US or UK.
Mm,
These countries are a biggest manufacturer of software or OEM or something. If
mm.
tomorrow they, share certificate like that, how do
Mm.
we trust? I mean, if
No,
there's a
see,
breach of,
see, the thing is, understand, try to understand. Here, the countries or the companies representing those countries have not done it authentically. They are not
correct,
responsible.
correct,
They have not done it.
agree,
It is attacker who had written a code in such a way that it acted as if they have obtained the proper certificate, whatever is been given in whatever format, ways, certified procedures, and it gave impression that that is the genuine one, and nobody
correct,
should take a doubt on it. That was a smart play of an attacker, and that was believed, not detected, unless it was investigated further.
correct.
But sir, how an unauthorized person use that pen drive in such secured nuclear power plant?
See, it's
That
not
may
like
be.
unauthorized person using pen
Mm,
drive. Use of pen drive was very common.
Correct.
It was, see, even you see the example of our case in utilities in India, we use pen drive very commonly, even in control centers,
For data copy and
whatever.
or
but sir, that is
So
used
it can't be said
internally,
that
not like.
it was due to the unauthorized. It was from the insider only using pen drive, because use of
Okay,
pen
okay,
drive was
yeah.
very common at that time,
Yes, sir. Yes, sir.
isn't it?
Okay, sir.
Okay.
the
So, coming to the constraints and security requirements which should have been given thought on, or lessons learned out of this Stuxnet incidents, uh, whatever things I told, that speed of a centrifuge which was seen, and you must have seen in my previous slide, indicator giving some idea about the pressure of a um, gas UF6. So it gave impression that it is correct, reporting correctly, but whether it is really happening or not needs to be ensured, and uh, physical endpoints should be checked. That is the first system security requirement which we needs to see into. The system must only perform, what was the next constraint? System must only perform operation requested by legitimate operator. Now here it is expected that only who is authorized should act, but it needs to be ensured. But in this case, it was not possible. because the operations were from remote, not detected. Thirdly, the system must recognize any tampering of critical core functions such as process monitoring. Here, what was the process? The process was centrifugal functioning to isolate the isotope. So the tampering with that itself was done and it was not detected. Next, the direct link between the SCADA and physical point. It must be ensured that all communication between SCADA and physical endpoints are not modified by anything, any attack or like eavesdropper. But that was not made ensured of during that case. Then whatever actions of PLC reflecting into the SCADA actions, they were not in the time frame, but they are expected to be. So this is a checkpoint which one has to focus on as a lesson learned. So in short, with this, we end our earlier case study, that is Stuxnet attack, and coming to the next one, that is a black energy. Black energy is a Trojan, has conducted DDoS attack and espionage and resulted into the destruction and attacks. It's again a very typical, peculiar case of cyber warfare. In fact, one can say that this is the first example of cyber induced power outages. Okay, how we'll see it? It began much more, again, it has a background of hostility between two nations, Russia and Ukraine. And it is also said as a battle of or war of bits and bytes, because the manner in which this codes play their role, those codes take form of some malware, etc., and affect the systems. So it's a bits and bytes which is bitting the system. Okay, so uh, during 2015 and 16, many such attacks were seen, and malwares were sabotaging the power system in Ukraine. In 2016, Ukrainian power system had experienced attack of industrial malware, which directly controlled the circuit breakers and switches. That is a physical system. Till now, what we have seen is a cyber system or a control system, that is ICS, which is called as, was impacted. But here the physical system was impacted. So what happened actually? Much before Russian invasion on Ukraine, there were Viper attacks targeted against Ukrainian agencies, companies, including power companies, power sectors, systems, which wiped out all the data, which leaving no stress to trace. Between 15 to 14 February 2022, Ukraine has experienced more than 3,000 distributed denial of services attacks, that is DDoS attacks on power sector. Now, just to give you an idea of the quantum and all the uh, perimeter of attack, let's see what happened actually. This is a geographical map of Ukraine, in which three states, including a state capital, that is national capital Kiev, which is very much in news in last 1 year, including Prikarpatia and Chernivtsi, were focused. So on 23rd December 2015, the Kiev and Prikarpatia and Chernivtsi Electric Control Center HMIs began opening and closing of circuit breakers without inputs from operators. Because of this, 225,000 customers across Ukraine got affected and loss of 130 megawatt of power, with operator having no control over system operation, but he has to send people, technicians at the site to handle and manually control the power system. So all the automatic controls were off and manual mode of operation was adopted. So what was happened actually? It is again a combination of mix of various things of attacks in different dimensions. First, launching a coordinated attack on UPS, that is uninterrupted power supply, with firmware such that UPS was turned off and numerous computers were corrupted. Then telephony denial of services attack was initiated, which seen the flood of call centers preventing legitimate calls from getting acted on. That is, there was a flood of calls which were interpreted by attacker coming to the telephony system, IP-based system, which refrain the actual legitimate calls to be acted on to restore the supply. Then firmware of RTU and serial to Ethernet port was also attacked. Now, I skipped purposely that earlier slide because I'm going to explain that further. So what happened actually? So this is how the extrapolated model of network and black energy attack, where you can see a corporate network, a SCADA network, HMI, a physical system like relays, a representative one like overcurrent relay is shown, substations, then communication system and malicious actors working. So this attack has, if you study, has 7 stages. First one is a spear phishing. In March 2015, malicious actors used spear phishing to compromise hosts that allowed access to targeted networks. And what it did, it sent a messages files posing it to be that from Ukrainian energy minister or ministry. So people used to see it, people clicked it, and the moment it clicked, the attacker got access to the system. Stage 2, the malware used to explore and move into the network. So this B3 malware had internal movement once it got root into the network. Stage 3, the credential were obtained. Now here I would like to give one brief regarding how the power system in Ukraine operates. As we know, in India we have uh, various states working at state level. There is a regional entity called RLDC as far as system operators are concerned, working at regional level, and there is a national entity at, as far as are concerned, grid operations are concerned, working at a national level at national load dispatch center. In similar fashion, in Ukraine there are regional entities. So out of multiple regional entities, whatever 3 names I have shown on the geographical map of Kyiv, Praktikoria, and Chernivtsi, they, each of them represent one regional entity. And in Ukrainian world, they are called as a Oblenergo. And that is the reason I have written attack on Oblenergo network in Ukraine. So in one such attack, in third stage, the Pricarpatio Oblenergo directory of computers was compromised of, and it's by brute force technique the stored password was accessed to. In fourth stage, the virtual private network tunnel was created, and uh, malicious actors use standard remote access tools to gain access to control system like HMIs, RDPs, etc. In fifth stage, compromise and reconnaissance of HMI computers was carried out, and malicious actors interacted remotely with the control systems. In next sixth stage, entered the actual, which makes it different than all other attacks which attack the IT system or ICS system, but it attacked the physical systems. What happened? The first Oblenergo manipulated initial circuit breaker at 3:30 p.m. Eastern European Time. Attack on second Oblenergo began 1 minute later, that is at 3:31 p.m., and that on third Oblenergo approximately at 4 p.m. The operators were able to watch, but they were helpless. They were unable to do anything because uh, the control was taken by the attacker, and they had nothing else left but to see what is happening in front of them. But the smart thing they have done is at 4:10 p.m. utility operator responded to the outages at one of the Oblenergo by disabling the HMI administrator account and shutting down the system. But the moment this was done, the smart attacker used another HMI administrator to get access, and it continued working. Then in this stage, operators took SCADA system offline and went to manual mode, which was the only way left to restore the power grid. The approximate time taken by this cyber attack was around 1 hour, and attackers disconnected circuit breakers within minutes of each other. Attackers also tried to operate relays as they controlled bulk power. In second stage, many calls were flooded to the call center, posing them to be attended by the operators and leaving actual genuine calls to be neglected. So this resulted call center operation and actions coming into the picture stalled. Then UPS remote access and shutdown was carried with the firmware attack at Kiev Oblenergo and Precatipia Oblenergo. So the moment the UPS support gone, most of the system went into the dark. So what were the sources of this black energy? It was Microsoft Word, software like TeamViewer, Java updates, bogus Flashware installer, compromise TeamViewer installed, Microsoft bogus systems, backdoor files, and fake integrated drive controllers. So Visual Basic Code was manipulated in this, and it's sent as a macro for access. So what was the initiation? A mail was sent, and this attack was carried out by a team or a group called Sandworm. So what they did, the macro which I shown in the previous slide that was sent, it was supposed to be as a government official mail needed to be acted upon, and it resulted into having an access. Next initial step was malware program named Mimikatz was used to get access to sensitive information such as password and credentials of the system, and then it spread laterally into whole of the network with VPN credentials known. In next stage, intruders hijacked HMI, got control of SCADA and ICS systems, and UPS was also attacked. During this, attacker uploaded a new UPS firmware. They didn't stop with just uh, firmware just being disrupted. They installed new firmware, which,
Sir, sorry to disturb you. One hand is raised by Mr.
yeah,
Sir,
yes,
Anil here. I have a
uh,
question.
yeah,
Uh,
Anil from,
in Anil from ERDA,
okay,
right? I have just seeing this scenario, the password authentication, right?
hmm.
So if it is a two-factor authentication, then will it survive such kind of attack, or it will require some other protection also?
See, the thing is, it is very difficult to answer this question because in practice, what we do, we have uh, say segmented or fragmented our password authorization in general. In Indian context, let me tell you what we do. We have something like administrator password, we have something like operator password, we have something like engineering password, right? In our system, you may be aware of, isn't it?
Yeah, right, right.
Yeah, right. So even if we have this type of three-layer password system, because in this, whatever actions which administrator is supposed to do, he cannot do the operator's actions. So way the engineers, right? So this segmentation is already there. So whether the password itself, even if it is whatever kind of layered use could have protected or not, can't be guaranteed, because attackers is also smart. They know, okay, so how to break and get access.
But still, how to get control of say fragmented or segmented password authentication? That is one big question. Na?
Yeah, that is true. For that, the general thumb rule which most of the uh, cyber expert or niche like institutes they give is use uh, password which is complex, not routine one. Like don't use the password which are from the list which are blocked or said to be prone for attack. So also change your password periodically. At least within 90 days, you should change your password. This is expected, which we hardly do, isn't it? So
No,
such like small precautions which we have to take.
yeah, you are
But sir,
rightly said. You are rightly said. For say individual password, that is fine. But for an administrator account, that has to be there, and that has to be complex only, right?
Hmm,
That is there.
hmm, hmm.
The submission is that how do we count? How do we protect ourselves? See, we give any complex password, some kind of system storing will be there. Somewhere it will be stored in some systems, right? Maybe in an
Right.
encrypted format, in a
Yes,
hashing
yes, yes,
format,
yes.
right?
Yeah,
But
right.
the dynamic, you can say keys or some dynamic numbers or segmented password,
Hmm.
it is quite difficult.
See, the thing is, another way suggested by experts is use combination of alphanumeric special character password if possible. Okay, and don't use the factory set password. See, if you are from Arida, right?
Yes,
Hello.
sir. Yes, sir.
Huh.
Yes.
So I don't know whether you are aware of the manner in which the password setting is done in utility in India. Do you have any idea of it?
No, I do not have idea, but as an administrator account, some,
No, the
yeah,
thing what is done generally in India or utilities worldwide without taking much of a precaution is whatever a set password is given, same is kept. That is the first blunder which we do.
correctly said. Yeah,
Huh?
correctly said. I
So
do
that's
agree.
what
Correctly
I
said.
have
Yeah.
done. And such password are known to everyone. Attackers are very smart. They know better than you what these things are. They know what Siemens sets their default password, what G sets their default password, what is Otter, whose password is Otter is. Okay. So we should take this type of precautions.
Right.
Okay. So coming back again to the discussion, what what was done? There was a program named Kill Disk, which wiped out system files and master boot record of key systems, disabling them from recovery. So even if anybody wanted to recover, there was no chance of getting recovered from any systems. So this precaution was also taken by attacker, that not to allow them to have a recovery of any kind. And because of this, 30 substation breakers were disconnected by using HMI. Just imagine 30 substation breakers. So what happened? Attacker enters substation gateway, HMI, breaker controller, and operated breaker, affected the power grid. So what was the sequence of attack? A phishing email was sent, VPN credential, password credentials, compromise access, then malicious firmware deployed to affect the UPS operation, DDoS on telephony resulted in attending the preventive maintenance measures and actions taken, and UPS support block due to newly written firmware. So also any recovery impossible was made out impossible due to kill disk overwriting on the system. So all that has resulted in the blackouts. That is a state in which there is no action can be taken in case of power system which has entered into emergency control not being acted upon and resulted into blackouts in Ukraine. So what is the parameters and perimeters for this? We should have a robust control system, identify risks and develop plan for it. In general, I'm talking about implement effective controls to manage risk, have defense in depth. So what is actually the defense in depth approach which we can have in general? We have, it's a layered approach.
Sir,
In layer,
before
yeah,
before we discuss defense in depth approach, we have
uh,
a question from Mr. Surendra Kumar. He has raised his hand. Mr.
okay,
Surendra, may I
fine.
ask your question?
Yes, 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 please.
Uh, Hi, hi, Amit. Surendra
Yeah,
here
namaste,
from
sir.
Vincent Infrastructure.
From where, sir?
So, my question,
From where?
Vincent Infrastructure. Vincent Infrastructure.
Versant infrastructure.
Yes. So the question is
What it
that
deals,
he
what your company deals with, sir?
deals with us in the solar.
Solar. Okay, fine.
Yeah.
Thank you.
We are
Yeah, please.
managing of the solar O&M. So the
Okay,
question is
okay.
that
Uh,
as per my plant visit and as per my observation, I found that there is multiple OEM product just like PLC or Modbus converter or HMI. They
mm,
use a default password. They
mm.
don't use a security or complex password. Why
Mm.
why they don't follow the security compliance?
I think though I am supposed to ask this question should be asked by those vendors, not me. But since you have raised me, I will reply it. Okay. I think you agree with my statement,
Yeah,
right?
I agree with it.
Okay.
Right.
Keep lighter part apart. The thing is, see, uh, if you see the working or a functioning of systems or engineering done or say commissioning activities done nowadays, it is uh, not only in COVID period but much before than that, and even today it is on or remote. Your engineers coming to the site always you see is taking support from someone in the factory or some expert outside the premises where he is working. And it's very easy for OEMs to have one password because they have commitments to supply many things, many locations, many plants. So they make their task easy and keep a very simple common generic password, which even a rookie, generally if you see those engineers who are coming, most of them are newcomers or not having much of a experience, unless you demand for an experienced person to be sent, because there is a scarcity of expert engineers which are involved in the commissioning activities at field level for systems like various application IDs, RTUs, relays, etc., or CRP, etc. Okay, so they adopt a approach of having a simple password which is not forgettable, known to everyone. If even if a engineer particular, this is actually uh, things happening into the system, because I am also in this field for more than 20 years, and while handling site activities I observe that if a engineer comes today, there is no guarantee that after 8 days for a second commissioning or field activity the same engineer will be there. So if that vendor or OEM has to handle such situation, he cannot keep his things of operations complex. He has to keep it simple. That is one way. But as a solution, what we can do is immediately after as a precaution to avoid this kind of scenarios met, Immediately after he said commission, we should have a strong password at our end. That is our responsibility as a field engineer. Okay. I hope I answered your question.
Okay. Okay.
Yeah, Amitji, OEM majority of the things, always they say that do not use antivirus, which is not recommended. So there are a lot of next generation antivirus which act, much better than the traditional antivirus.
No, I don't
Uh,
think any OEM suggests that don't use antivirus.
no, no,
I
I'm saying
haven't
that
uh,
they
I haven't come
always
across any OEM saying don't use antivirus.
they recommend certain antivirus which we are supposed to go with, not
Hmm.
the next generation
Better
one.
ones
They
which
could,
are available into the market, which is what you are
yeah,
saying.
yes,
So
yes, yes.
for that, then it is up to us to see, considering overall parameter, as to what we need to go. After all, it's your work, your system. You
Correct.
need to decide as get the things done, not to
So,
accept and succumb to the OEM pressure. That is
no,
up to us. We are
only
giving.
only thing is like if we go with not go with their suggestion, then tomorrow if something goes wrong, they will raise their hand. I mean, they will
No,
say
that
that it's
nothing
not
like
our
that.
baby or something.
No, nothing like that. They can't say that. If you say QR tendering document and what they are supposed to do, quality plan at site
Correct.
is properly written with the OEM responsibility quite properly charted out, I think they cannot escape it.
So,
And for on that matter, we as a utility engineers also have to be uh, more educated, matured one to handle such situations.
agree.
Okay.
But sir,
So,
in IoT environment, we can't use any software without confirming from OEM because all software does not support some control systems like in ALSPA system of GE Power that
That,
support a
that is what
particular.
I that is what I that is what I mentioned in the previous slides that
Yeah,
in case of wind, if it is Siemens, they have their prolific. If G they prefer something else.
yeah, yeah.
So I even though there is a standardization, uh, there is say you can say hegemony of OEMs, which needs to be uh, tackled smartly, coming together as a utility engineers together. It's not one engineer, one utilities role. There has to be a
At
say,
engineering level.
yeah, means at working level, at the utility level, everybody should take a common stand that this should be there. And even if he gives an example of ABC utility, DEF also is going to say the same thing. If they are imposed like that, then they have to accept it across the nation. And for
Mm.
that, regulator also has to have a play a role. But unfortunately, here regulator hardly comes into the picture, or the policies, regulations, standards which are framed in Indian context as far as power system is concerned, they hardly point out any such things. The kind of standardization which US has, despite of that, they face such attacks. Just imagine if we had an automation of the scale which they have, and with the poor quality of standard procedures which we follow, with how much prone we are.
Yes.
Anyway, coming back to the discussion, defense in depth. So actually, this is six layer, which suggest the bottommost zero level is a physical layer where your physical system like physical equipment, circuit breakers, and all the power system equipments are present. Second level will be protection or metering, relays, meters, etc. Then there is a automation layer. Then there is access control. Then SCADA. Then you have a perimeter defined with the firewalls and all. And lastly, there is persons or a people who handle this system. So if we have such segregated approach, it can quite well protect and design properly, quite well protect or shield system from cyber attacks. Now, what else we can do? See, in case of suppose, in case if we face a cyber attack, what we can take help of again. I think we should go to the big companies like big IT companies like Microsoft, who can help organization institute to defend an onslaught of cyber warfare. Because in many of the cyber attacks, you see that it is a Microsoft systems which is compromised and attacked. So we can take help of them. So also routers, modems, etc. This for this, I have given one name. There are many multiple factors or multiple companies. You can just understand what I mean to say out of one example. So we can take help of company like Cisco to kill the large number of remote access trojans and which are gaining control to the computer system. Google can help us protect websites from any of the viruses, malwares, etc. So also the companies like Twitter, that is X, Meta, TikTok, YouTube can help us through their huge data or big data and data analytics tools to monitor and take actions on malicious activities. Now, in short, in general, what we should have as a shield or a protection, seven commandments, what we would call, to protect from cyber attack. That is, isolate control systems, baseline log, continuously monitor the control system, have proper patches, updation of patches, maintain them well, keep your plan B ready, contingency plan ready if one plan fails. Be truthful after any misincidents happens. Report properly, don't hide anything, and accept the lessons learned, not to repeat it again. Ensure physical security, ensure complex passwords. Then a NIST has suggested a core framework for cybersecurity, uh, which gives various functionalities like what processes and assets need to be protected, how to identify it. Like there are just few given, but there are many like this, not included all. But there is something for everything in power system or power sector. Like nowadays we have all the asset being managed under asset management. So for that, how to identify, we have our business plan, business management. So for that environment, what we need to do for governance, risk management strategy implementation, supply chain risk management, etc., how to identify, etc. Then safeguarding, that is protecting with identification and management, data security, maintenance. Then detecting, how to detect anomalies and events, security monitoring, detection process, what it should include, use after uh, incident happen, what is its impact, how to assess and respond. So how should be the response planning, how should be the communication, what way the analysis should be done, how to mitigate it, what are the mitigating techniques out of multiple, what should be used. Then if the existing mitigation techniques are insufficient, then what could be the improvements done. All that needs to be focused on, develop and design. Then next, what techniques can help us restore the capabilities of a system. So for that, what is the recovery plan existing? What should be the additional one and future which we can consider? What improvements can be incorporated? And what sort of communication we should have? All that has been given, described in this framework. So there are many things like this. If we abide to that, many of the problems like this cyber attacks on the cyber system, physical system, or CPS system or CPPS system can be avoided to greater extent. Now coming to the last part, that is which I mentioned in the beginning, that while answering what could be done in such scenarios, there is something we should focus on, though it is not talked much in uh, here in our world. We should have, each of one should have, first assess what is our cybersecurity capability. Then we should understand where we are, where we want to go in days to come, months to come, and years to come. So we need to have a plan for that. We need to prioritize our criticality, and take steps to address that criticality. We should evaluate whether that criticality identified with priorities set are met. Then we should have reporting as to whatever objective we have set as a priority and met with a action plan, where with evaluation whether it is rightly reported and delivering as per need or not. If not, there is a scope for correction exist. So in short, we should start going from the process of crawling, walking to running, instead of just going to the run mode where we are bound to fail. Then there are different domains. This C2M2 model, that is cyber security capability maturity model, which all the organization utilities which should focus have domains specified, like what are the asset, what changes are going to happen, what configuration system we have, how to manage it, what are the situations which can arise, and how better situational awareness we can have if current one is not adequate. What should be the architecture? Now I just gave you the architecture simple one of cyber physical. Like that, there are n number of architectures of cyber system, cyber physical system, communication system, IT system, control system, protection system coming together. So how it should be architectured with all these ICT technologies, that is, it's not interconnecting transformer but ICT technology. There's information communication and uh, our uh, technologies coming together for physical systems act, how we should architect, have the architecture for normal system, RE system, industrial systems, etc. That we should focus on. Then what are the third threat perceptions? What are the current vulnerabilities? What are the future that could be? See, the one important thing which we need to see or understand from all these attacks is that these cyber attacks give you a further direction as to where the attack dimension of the future is going. If you study the current attacks properly or the past attacks properly, you will see where the next trend would be. So definitely those could be your threats and vulnerabilities, which should be focused on with a priority to address and its management. Then the response, how we are going to respond it, what incident response we have, if it is adequate, what value addition we can do, how to achieve continuity of operations, etc. Then what security program we have and its management, risk management, and most importantly the third party risk management, like whatever third party systems, vendors, etc. we have in our system, for that how to manage the things, risk coming out of it. Then access control, identify and access the management, as I mentioned, have AAA approach, do not allow anybody to access anything, have restrictions there, watch it. Then lastly, the workforce, that is whatever workforce like you, me, whoever are working, we should be uh, trained properly to understand the challenges of current and future, so that we understand and can deal it very nicely. And I think with this initiative of CEA and CBIP, and with your presence, I think we are going a good step ahead towards this last point of workforce training and management. After that, there are some aspects which need a focus of policymakers. Like most of the things which are being discussed, or we talk about, are origin out of India, that is in USA, Europe, or China, elsewhere. We are not that matured yet to that level. We are evolving. So, what we should have, power sector specific standards, country specific standards for periodic reporting, assessment, data sharing, collaboration, compliance informant, control system security mandates, corporate system management, business plan developments, security of organization, security policy management system, that also must be focused on and worked upon and implemented further. So To conclude, in general, what approach we have to avoid these attacks and keep our system safe? Ensure cyber resilience, and it's a responsibility of all stakeholders. It's not a responsibility of a single stakeholder. It is the responsibility of all representing the value chain. As a state utility, I am responsible. As a vendor, you are responsible. As a RE developer, you are responsible. As a OEM, you are responsible. As a retailer, you are responsible. As a market operator, as a system operator, we all should take own the responsibility and have our part played its role. Then clarity in institutional responsibilities. Who is to do what should be highlighted and to be done accordingly. And one solution does not fit all, as most tools like any of the malware are tailored for to meet certain specific targets and state perception. So also they have a solution for that particular. So we should, though take some learning from that, we should be ready to evolve and act accordingly. Key elements in product certification. Here, the one who is responsible for deciding about a product to be certified, how to be certified, uh, on-site committee to monitor the certification, etc. All these things should be included. Continuous assessment is essential to have cyber resilience against cyber attack, considering criticality and priority. Maturity model self organization assess its cybersecurity capability and potential progression to a higher degree of preparedness. Risk management practices should be adopted with priorities, efforts, and investment done to achieve higher degree of cyber resilience. Detailed plan to execute response and recovery, which is very crucial to have resilience with respective mock drills done periodically. Partnership, information exchange programs, research initiatives will all add to the value of preparedness against cyber threat. Formulation of effective cyber resilience regulation is a delicate balancing act between enforcement and innovation. It should start immediately with inputs from all the stakeholders. Then, implementing strategies should be tailored in the national context, seeing national challenges, but with an eye on global nature of risks. I think if we follow all this, we can have a with our training, our learnings, our efforts, has safe grid and operate grid safely. I thank you very much. I thank you a lot for your patient listening. Thanks. Thanks.
Thank you, sir. Thank you.
So are
ERD.
there any questions to Kulkarni sir?
Yeah, yeah, yeah. This is Anil from ERD.
Hmm.
Sir, is there any, you can say, applications or softwares to check that any smart devices putting it into operation, that smart devices are infected or not?
Means you mean to say that is there any software or application which can detect whether the device or any instrument or appliance is infected or not?
Yes, yeah,
See, exactly to reply this, there is no such thing, but there are softwares and systems which can tell you if something like infection is happening or not. Okay, means
oh,
if suppose to give an example, uh, you may be knowing SEMs, right?
yeah, right, right.
Okay, so if suppose you are seeing the data of a SEM, right, and you know how much is the data it is in interacting in exchanging periodically from one point to the other where it is supposed to do it. But
Right.
with your monitoring, if you find something abnormal in it, you can definitely uh, see the smoke coming out of it. Means you can doubt that there is something abnormal happening and you can check it. So there are this kind of ways. of monitoring, and there are
Okay.
softwares also available for it.
That is again the kind of monitoring only, na, say kind of
Right.
say a VAPT, right?
Yeah.
After
Right.
putting the smart device into operation, we have to do the VAPT at a frequent interval. That is
Hmm.
one way, right?
Hmm.
Are there any ways or approach that
Hmm.
we can check that smart devices are infected or are designed in such a way that it will send some data to XYZ, right? So we can check that whether it is infected or not before putting it into operation.
Okay. Now, before answering your question, let me ask you a question. Answer to that, uh, addition to it will be my answer. Okay. Are you?
Okay.
Am I audible?
Yeah, yeah.
Yeah. So your question is, I'll repeat it. Please correct me if I'm wrong. You mean to ask me a question if there is anything, any process by which infected smart device can be detected.
Yes. Any approach or any
Yeah, yeah,
method.
that is what any technique
Yes.
method, right?
Yeah,
That can be
yeah.
now, let me put you a question. When you mean a smart device, which smart device you are talking about? First thing. Secondly, what aspect of that smart device you are talking about? Second thing. Third thing, what design aspects you are considering of that smart device? Third. Fourthly, what are you looking out of that smart device?
Okay.
If you answer this, I think I am partly answering you.
No, you had answered it majorly. The
Uh,
only thing that we should be aware that at what aspect we want to protect it, right?
yes, right, exactly. Then on that you are able to see as to what needs to be done.
Say, for example, smart
Hmm,
IDs are there. I want to
hmm,
check communications or interfaces, right?
hmm, hmm,
Then I have to check how many interfaces are there and how they are interacting,
hmm,
right?
hmm.
But it is possible that design manufacturer or designer would
Hmm.
had given some you can say hidden interfaces that is not none, right?
Hmm.
Or say it's a design you can say device design itself
I
in
understood.
such a way.
I understood. Let me put your question. I got your point. You mean to say that if a smart ID. Now, before answering that, let me know. Try to give your answer better way. Uh, what smart ID you are talking about? Because the moment you mention ID, it is a smart. So there is no need to say it as a smart ID.
Yeah, smart. I mean to say
Okay.
smart ID means
So,
smart devices. Yeah,
huh?
I mean to say the devices which are communicating or
Huh.
through interfaces.
No,
Yeah.
you can't say that device which are communicating are called to be a smart. That is not the definition of smart device. Okay.
Okay.
Smart
Okay.
device is a one which has the capability to act as per whatever interested functionality it is supposed to do as on its own.
Right.
Okay. So if you say your device is connected to the communication system, so it is smart, that is a wrong perception. So correct
Right.
it
Right.
first. Okay.
Okay.
So coming to your question's answer, you want to understand, is there anything which is not supposed to be there in smart device which is there? How to detect it? That
Yes.
is your question, right?
Yes. Yes.
Am I right in understanding?
Yeah. Right.
Huh. So for that, I think this can be addressed at the time of fat which you do. Since I don't know whether you are involved in any fat or not. So
So,
if you do
wha-
a fat, during that you can very well understand this as to what is the device you are offered or you have asked which is being offered and what is being given. If you check at that point itself you will understand. But above that, if you want to understand, then it is next to impossible for a third person to know what OEM is providing. Okay,
yeah.
because
Perfectly.
uh,
Perfectly. Yeah.
because because the thing is, uh, few years back, around a decade back, many of the Lenovo laptops
Yeah. Right.
given to the USA were found to have a chip which was illegally put by Chinese.
Right.
and all the data was getting transferred from USA to Chinese systems.
Yeah,
The
even
moment
that.
it was detected, so this is difficult to understand. So, but what, there is a trust, again, there is a trust factor. Okay, so you should go to the OEM only those whom you trust, and
Rightly
you
said,
should
sir.
not go to the, you should not go to the OEM which are from your hostile countries. But
You
unfortunately, in India, we are to go there.
you rightly said, but we cannot trust even OEM, trusted OEM also, because Sun
Mm,
Solari system also compromised, right? As you said,
mm,
Lenovo also, Sun
mm.
servers also there, even Apple systems were also there.
Everyone say they are
Everyone.
they,
So
they are there
how?
to be, do
Yeah.
business. They are not there
Yes.
to do a charity.
Ah. So, or any approach or methodology that after doing that, say we can have at least certain assurance. Okay, I have checked this much parameter. We cannot
So
give
that
assurance,
is that is
but
that is whatever expected is coming or not out of your tests, that you can check at the time of fact.
right,
That is there in your hand. Apart
that is in
from that,
our
suppose a device is compromised. If suppose four and half portion is kept, which is compromisable, you won't be able to detect it. Let
rightly
me
said.
give you an example in this context. In case of that Stuxnet, the daughter boards were infected. Do you know what is daughter board?
It's a card only, no, mother.
No, but what its function is?
Function exactly, I am not aware.
Okay, so let me tell you, the daughter board is very much similar like a motherboard. Motherboard is a one which is responsible for doing all the activities, functionalities, processes. Whereas daughter board is a one which is connected to motherboard, but it is supposed to give the additional application assistance. So that was
Okay,
affected. So if
right.
suppose tomorrow a particular company puts a daughter board with motherboard, you won't be able to detect it unless you dissect it,
See,
isn't it?
that is, yeah, that is the query. Now, see, I bought one server, right? In that server, that will a number of different OEMs parts, right? Switch will
Hmm.
be different, port, fiber port will be from different OEMs. Number of OEMs are involved in a single server also, right?
Hmm.
So that is the way, that is why I had asked you question that how
No, the thing
we,
is that is the reason you should have your specifications very rightly put.
yeah,
That what is the specification, how many ports you want, what should be the specification of that port, what kind of port, what specification. Then from that itself, you are indirectly
no, that,
expecting what the vendor should come and
that is
put
there,
a.
sir. Non thing we can do, we are doing, that is right. Non
Hmm.
things that we should do A, B, C, D, that we are doing, but that is not enough for say, that is
Yeah,
not
that
the
is true.
guarantee.
And that is the reason I said, for doing or knowing unknown things, there are, say, for example, you cannot detect a hardware component put extra in a device unless you break the device and see it. Means unless you dissect
Right,
it, right?
right,
So it is
right.
next to impossible. And it has a warranty. Even if you wish to do it, even if you ask a relay manufacturer, when you are going to their test the system at their premises and ask them, open the relay and show me, he will tell, okay, I will do it, but I will not have a guarantee of a relay given afterwards after opening it.
Yeah, perfectly.
So that is a practical difficulty.
Right, right. Okay. Thank you, sir.
Okay.
Neeraj sir, any
Sir,
question?
Yes.
yeah, I'm having one. There's a related to, sir, this one is a follow-up to the one which has been just asked with regards to embedded malware in
Hmm.
hardware and all.
Hmm.
So there's a standard called
May I know who is this? May I know who is
Neeraj
this?
Sharma. Neeraj
Neeraj
Sharma.
Sharma. Neeraj Sharma from, I
So
forgot from where? From
from CEA, CZ Power CEA.
CEA. CEA.
Yes.
Okay. Hmm. Yes,
So
sir.
there's a standard 20243.
Hmm.
So
Hello.
this is for, hello, am I audible or?
Yes, yes. In between your voice is breaking.
Yeah, yeah, actually
Okay,
I'm
but
driving as
now
well.
it is, now it is audible. Please.
Okay. Sir, to my point is like, for the ICT products, there is one standard called IEC 20243
Hmm.
OTTPS standard is there. ISO IEC 20243 that is meant for testing the
ICS systems.
malicious, yeah,
Hmm.
ICT
Uh,
systems for
ICT system.
tentatively malicious products as well as counterfeit products.
Hmm.
So do we have any facility as such with regards to internationally, globally? I just want to know because certification is there, but do we have any facility under that certification with so as to check the embedded malware in ICT products at least?
I think, see, for some functionalities you can check it, some of the installation. I don't know exactly where, but Europe and US you have it. But what functionality I'm not aware of. Okay, first thing. Secondly, as far as malware is concerned, you cannot have a guarantee of checking it for all the malwares, because you are talking about, you are known to only those malwares you are known about. What malwares are going to come today, tomorrow, you are not aware of. So from that angle, how your system should respond, will respond, you can't guarantee.
At least from supply chain aspect, at least we can be assured of, as you told in the beginning, we need to
Huh,
rely upon trusted vendors only. So at least the
right.
trust component can be ensured through this supply chain, through the such standards. Yeah, at least if
Uh,
not hardware, at least supply chain can I be assured of. No?
yeah, see, in case of supply chain, there are various standards available, which uh, this vendors do add up, but not like in perfect in toto. Most of them compromise many of the things. So it is up to us as to know what the things are. Like, see, it's a ICS system. Then if it's a controller, then we should try to see as to if it is a Windows based, Linux based controller, or any open source control system based controller, then what are the standards which define the functionality or a functioning of that ICS system? If it is Windows based, if it is Linux based, that we know. From that we can chart it out whether the vendor is providing as per that or not. That is there in our hand.
ठीक है, but there is no testing or mechanism or
Yeah,
facility. Lab.
facility. See, some of the NIST facilities do it, but what are they and what are not involved, I am not aware of. So I can't answer directly about that. Okay, but NIST is having, even NERL has set up some of the labs to check uh, such things, cyber physical interfaces, smart grid devices incorporated into cyber physical systems. But what functionality they address and what are left, I am not aware of.
Because there are many of times, as I could recollect from the past discussion, you were talking about the fat testing and all. No? Fat and
Now,
SAT
fat is
testing. So
different.
most of the
Fat is
time,
different.
yeah, most
Fat
of the
is
time
different.
only functionality
See,
is tested only.
no,
Yeah.
so see, the thing is, fat is different. You are mixing the two things. Fat is
No, no.
different, and the system which you are asking is a different. Fat, I
Right.
talk from the perspective of any device. Say, for example, numerical relay. If you are taking from vendor A, you generally test it at its factory premises. So you know the procedure specifications, as the specification is set by you itself, and as per that vendor is providing. So you just have to check whether the set
The only
systems,
functionality part
yes,
is
that
tested,
you
no,
do
sir,
it.
not the cyber aspect.
Yeah, that is what I'm telling you. That is not done. And for that, what you need to have is cyber physical simulation labs, which hardly have, only Virginia Tech University is having it. Okay, or some of the NIST offices have it. But in
Okay.
total, if you want to have check cyber physical interface along with ICTs involving, the scope is wider. Let me tell you, since you are asking, trying to know in detail, let me tell you the depth and details it is involving. The moment you want to have such kind of a lab, its requirements are multitude. You have IDs. IDs are supported by different protocols. So you need to have a systems testing all those protocols, all softwares. You need to have it. Secondly, if you have say SEMs to be tested, you have its protocols, its systems tests. If you need to have communication ports, modems to be tested, you need to have it. So it's not having just this devices and systems together, but what is most importantly which you need to have is a hardware in loop functionality. Are you getting what I'm saying? And
Right, right.
with having that hardware in loop functionality which softwares run, it is a very complex thing. And just imagine number of devices, number of protocols, number of softwares, number of simulations. Say even if you have to have a relay or a PMU being tested in a closed loop fashion to check its closed loop functionality, you have to loop that relay or IED into the platform like Opal RT and then check it. And even after that, having that hardware loop in functioning before doing it actual into the system, you need to run the simulations. You need to write a code, do the things, see the responses, and then do the hardware in loop testing its responses and feedback. So here the vectors are your physical system, your cyber systems, your communication system, your IT system. Everything has to set up in a lab,
But do
having
we have such
established.
any such facility globally?
See, that is what I'm saying. There are some prototype labs available, like say you can say pilot systems, pilot labs, cyber physical simulation labs available in Europe and America. One of them is in Virginia Tech University, which but they do it
Okay.
on small scale, not on large scale, and that too yet to be matured to the level of a grid level. To having it at a grid level is a very costly affair, having multiple vendors, multiple systems, multiple stakeholders coming together, putting everything. To understand this point well, let me give you example. I'll take 2 minutes of yours. I think you said you are from CA, right?
CSET Power CE.
CSET. Okay, so you must be having a discussion, or you must have heard some point of your experience that there is problems of meters vendors not working with other meters specifications, supporting the softwares, etc. This might
Right, right,
be
right.
heard by you, isn't it?
Yes, yes,
So
of
if
course.
in case of one meter manufacturer, one device, if this system is there, this despite of they claiming they are complying Modbus or say respective protocol, huh? They are not supporting, they are not sharing the things. Just imagine the kind of difficulty in having coming together all these stakeholders and establishing lab along with its expenses. So it is difficult to operate it at grid level requirements.
You mean interoperability issues? Or?
Interoperability issue is one of them. That is not all. Like that, I just gave you example of interoperability issue just to make your understanding clear. As like that, there are many things which are there when you are bringing your physical system, cyber system, communication system together to put in for cyber physical simulation and knowing its response grid like grid wise. Just next.
Thank you.
So if there are no further questions, can we close the session today?
Yeah, sure. Okay. Once again, thanks a lot for all
Thank,
your energetic participation. And
Thank you,
thank you,
sir.
sir.
I also like the way you interacted and shown interest. And I'm hopeful that with this strong team of cyber warriors, we are bound to have a strong grid, cyber secure. Thank you. Thanks a lot.
Thank you, sir. Thank you for insightful session today, sir.
Thank you, sir.
Thank you. Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you. Thanks a lot.